Hi everybody, this is chapter 4, section 4 for our Math 211 class, geometry, and we are going to look at proving triangles congruent in this section by angle-side angle and angle-angle side. All right, so our first postulate is the angle-side angle postulate, and this postulate says if two angles and the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. Just as in the past section where I said we had an angle sandwich, now we have a side sandwich. So we have two angles and then an included side. So again, we have two angles that are congruent. So we have angle A and angle C on this triangle and angle D and F, and then the side included between them. And that is a way to prove triangles are congruent through angle-side angle. All right, so here we have four figures, and they want us to choose which two triangles are congruent by angle-side angle. So take a second, again, pause the video, see if you can answer the question, and then come back and we'll take a look and check. Okay, so hopefully you paused the video and you came back and you're looking at it. Now, if we look at A, right now we have an angle and another angle, and then we have a side. But remember, this is like a side sandwich, so the side has to be included between the two angles, and here it's not. So A is not an option. If we look at B, I have an angle and another angle, and then we do have a side. So this one would be proven by angle-side angle. C, we have an angle and a side, or excuse me, two angles, and our side is not included in between where it should be. So this one can't be proven with angle-side angle. And then if we look at D, our last one, we have an angle, another angle, and a side. So this one we can prove through angle-side angle. All right, so our next theorem that we're going to use to prove triangles congruent is the angle-side, or the angle-angle-side theorem. And this theorem says that if we have two angles and a non-included side of one triangle that are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. So here, the important thing to remember is you have two angles that are corresponding and then a non-included side. So, but it has to be that corresponding non-included side. And it has to be two angles and a side. You cannot prove triangles congruent through angle side. Just kind of think, bad word, not a way to prove things congruent. All right, so we are going to work to prove these two triangles are congruent. The first thing I'm going to do, put my statements and reasons. Okay, so the first one is going to be our given, and we know that ray DB bisects angle ABC, and that is a given. And I'm going to put that one first. And then I do know if I have a ray that bisects an angle, I want you to think, what do you know from that given? If you have a ray that bisects an angle, what does that ray do? It cuts the given angle into two equal parts. And if we look, and if I just highlight, all right, so DB bisects angle ABC. So here is ray DB, and here is angle ABC. So now I know when they put the numbers in there to help us, I can say angle 3 is congruent to angle 4 because of our definition of an angle bisector. Sorry, my handwriting is atrocious right now. All right, Now, step 3. Can't really get any more for my angle bisector. You get 2 angles, so we got that. So now we're going to go to step 3. I'm going to go back and use my other given, because once you run out of information, use your next given. So I know angle 1 is congruent to angle 2, and that is a given. All right, now, unfortunately, angle 1 being congruent to angle 2, I mean, it's good information. I'm glad they gave it to me, but I really don't have any other information from that. So now what I'm going to do is, and this is where kind of highlighting your triangles, I am proving that DAB, so this triangle right here, is congruent to DCB. So I'm proving it congruent to this triangle right here. And the way to prove those triangles congruent, you have to look at your picture. Like, what other information do I know? And again, remember, it's easy, but it's hard. We got that reflexive property in there. We have this shared side right here. So I can say that DB is congruent to DB through our reflexive property. Of congruence. Okay, so now, right now, I'm going to do a little erasing so we can look at the whole picture. Okay, so I know through my information that angle 3 is congruent to angle 4. Through my given, I know 1 is congruent to angle 2. And we also know through our reflexive property that we have this shared side right here. So how can I now prove my angles are congruent? I have enough information. How can I prove that DAB is congruent to triangle DCB? Hopefully, you can see we have an angle, a side, and an angle. So you said the angle, side, angle postulate. And again, the proof wasn't bad. The more you practice, the better you'll get. I understand you're not perfect right now. It's just more knowing the theorems and postulates and explaining your work. And the more you do that, the better you'll get and the easier it'll be. Okay, next we have another proof. And this time we are going to prove that triangle ABC is congruent to triangle DEC. So ABC is right here. And DEC is right here. Okay, so again, we'll start off with our statements and our reasons. Okay, so number 1, we're going to start off with our givens, obviously. I know that angle E and angle B are right angles because it was given to me. So angle B and angle E are right angles. And this was a given. And we talked about this previously. Just a reminder, when they tell us they're right angles, that is great information. But the next step you want to do automatically is we don't assume, we have to be told. So the next step, when they tell you they're right angles, you want to say that angle B is congruent to angle E, and that's going to be your definition of right angles. I know it seems silly, you're like, oh, I know right angles are congruent. That is true, but you have to tell people that. So definition of right angles. Okay, so now we have currently a congruent angle. B and E are congruent. I don't think I can get any other information from my first given. So I'm going to move to my second one. And C is the midpoint of segment AD. And that is our given. So now you got to ask yourself, if you have a midpoint of a segment, what does that mean? So right now I know that C is the midpoint of segment AD. So it's only this segment right here. So remember, a midpoint divides a segment into two equal parts. So that means that AC and DC are going to be congruent. So I'm going to say AC is congruent to, and again, you want to kind of keep the right order. So AC is congruent to DC. So we're going from the top to the midpoint, top to the midpoint. And that would just be definition of a midpoint. All right, so we've looked at our given information. We've taken as much as we can from it. Now, if you continue to look at your picture, what other information can you find from that picture? I notice here that they have marked angles 1 and angle 2. They've marked them 1 and 2. They haven't told us anything about them. But again, if you look at that, what kind of angles are 1 and 2? Hopefully you said they are vertical angles where we know that angle 1 is going to be congruent to angle 2, and that's going to be our vertical angles theorem. And if I look at my picture right now, that's really all I can see. I don't see any other information that I know. I can't tell anything about BE. I don't know that C is the midpoint of that because they didn't give us that information. I don't have enough information. But I have this angle, this angle. We also know this angle right here. They are congruent. And we know that this side is congruent to this side. So if you take a look at those pictures, how can we prove that our two angles or triangles are congruent? So we have triangle ABC, and we know that it is congruent to triangle DEC, and that is going to be through two angles and a side, but it's not a side sandwich. It is going to be angle, angle, side. Two angles and a non-included side. All right, so here we're going to prove our triangles are congruent through side, 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 angle, or angle, angle, side. If we look at A, this one should jump right out at you kind of automatically. We have all three sides, so this side is marked with 3 figures, or 3 hash marks. And we have one marked with 2. And then we have our third side marked with 1. So that one is definitely going to be side, side, side. If we look at B, we have 2 angles that are marked congruent on each figure. And then we don't have a side between the angles, but a non-included side. So that is going to be angle, angle, side, because it's a non-included side. It's not between the 2 angles. All right, and our last 2 that we're going to look at, for C, we again have 2 included angles. So we have one angle here, and then another one here. And then our side is between those 2 angles. So to prove these 2 triangles congruent, we would use angle, side, angle. And then our last one here, they've only marked 2 congruent sides. So we have our one side right here, and then our other side on both triangles right here. But is there another item that you can see that's congruent that can help you prove these triangles are congruent? Hopefully, you said, oh, look, I have two lines that meet at a point. So right here, I have vertical angles. We know vertical angles are are congruent. So that means I can prove these two angles are congruent through side angle side. And that is it for this section. Part of your classwork for this section and other sections in Chapter 4 will be to work on proofs and submit them through Blackboard.